Let's start to illustrate this another problem, and let's see if the pigeonhole principle, or better yet, the generalized pigeonhole principle is applicable to this, and then solve if it is. We have the question, what is the minimum number of cards that must be drawn from a standard deck to guarantee at least 3 of them are of the same suit? Now, this question talks about the standard deck. We know that the standard deck without the joker will have 52 cards. And the suits here are actually hearts, spades, diamonds, and clubs. That would mean there are 4 suits, okay? And then there are 52 cards. And we are asked about the number of cards that you will take from that standard deck of cards to guarantee that in your hand, you have at least 3 of them, which are actually all of them are hearts, or all of them are diamonds, clubs, or spades. So how do we know that it's a pigeonhole principle? Basically, looking into the perspective that our pigeonhole here, okay, the number of placement, again, if we're going to look at the pigeonhole, they are the number of possibilities for placement of all the pigeons. Okay, so we're going to look at the number of possibilities. Now, what would be the possibilities? Do we consider the 52 as our possibilities? The question here stands for at least 3 cards are of the same suit. It would mean, again, the 3 would be not necessarily red. Diamonds, they would be hearts, or would be spades, or clubs. That would mean the pigeonholes here are actually the suits. Okay? Because if we're going to pick one card, so for example, this is your spade, okay? This would be your heart door. This is your diamond door. That's your club door. So that would mean your pigeonholes are your suits, not the cards. Okay? You're going to determine how many would be needed and would you need to pick so that you will pass these doors 3 times, at least 3 times. Okay? That's the suits. So the suits are actually 4. There are 4 suits: hearts, diamonds, spades, and clubs. Okay, so hopefully that's clear now. The next time here is, what would be the pigeons? The pigeons here would be the number of cards that you will pick, which will follow the suits. Just like in the previous example, we have the students, which will follow their birth month. So the pigeons should follow the placement. Your pigeons should follow the pigeonhole. So when you have here the cards, the question now here is how many? That's the question. How many cards do we need to pick? In our definition for generalized pigeon principle, this stands for Kn plus 1. Because generally, if I talk about the non-generalized pigeonhole principle, it's just actually n plus 1. If the question here is not at least 3, if we say here at least 1, okay? So at least 1, or at least 2. So you would just need n plus 1, meaning 5 cards. Because if it so happened that in your first card, that's spade, then hearts, then clubs, then diamond, if it so happened that it's really distributed like that, your 5th card rather would guarantee that you will have at least 2 cards of the same suit. Okay? But that is for at least 2. Returning to the problem at hand, at least 3, it would not be n plus 1, but it's actually Kn plus 1. Hence, we'll need to pick a certain K. And where do we get this K? Our K will follow this intended target here, because that's your K. It talks about at least 3 cards. It would mean that this is actually your K plus 1. Going back to the definition, it tells us that if n pigeonholes are occupied by Kn plus 1 pigeons, then at least 1 pigeonhole is occupied by K plus 1 pigeons. Still, cards, because that's our pigeons. So this is your target. You would like to get at least 3. That's actually equal to K plus 1. Not K. Okay, take note of that, but it's the K plus 1 based on the definition. Again, try to review the definition for the generalized pigeonhole principle. With this now, our K is 3 minus 1. K would be equal to 2. Okay, so this is now our K, which will be substituted here. So basically, you will have here how many cards you need to draw. That's 2. times your suits would be 4 plus 1 is actually 8 plus 1, you would need 9. The minimum number of cards you need to draw from a standard deck of cards to guarantee that at least 3 of those cards will have the same suit. Okay? So, if you're not yet convinced with this, let's talk about it analytically. What if in your first 4 cards, you picked heart, spades, clubs, and diamond? Again, spread distributely. They are already spread, they are evenly distributed. What if in your next pick, you will also have heads? I understand that there's possibility that you will have hearts as well. It's not head actually, it's hearts. But let's try to look into the possibility of randomization, spades, clubs, and diamond. So at your 8th card, still, you have not guaranteed that at least 3 will have the same suit. That would mean in the next card, regardless of whether it would be hearts, spades, clubs, or diamond, that card will now guarantee that there are 3 of these 9 which will have the same suit. So, for example, the 9th one is spade. So, basically, there are now 3 spades. It now fits the criteria. So, our answer of 9 is correct using the generalized pigeonhole principle. We'll have more examples into this. We'll be looking at more complicated examples for more illustrations. Thank you very much for watching.